start there. So going forward, what really matters in your journey of any, whether you prepare for competition or you prepare for any advanced degree or whatever you want to choose in your life, whether it's sports, going forward, what really makes an individual extraordinary is observation. You need not to bond with this extraordinary skill. You can easily develop and you can move towards being a scientist or any researcher or whatever you want to in life. Of course, being an IITian or a doctor is a small achievement in this due process. You have to cross that barrier. But what really matters is to understand the process of observation. And after observation, what is the next step in everyone's life? Every scientific discovery goes through certain process. The first process we have understood, it's observation. So what are the other processes? After you observe, what you do next? So you observe something. Let's say Newton saw that apple is falling. The first observation. What we do next? The next is called?
Sir,
yes. Yes.
to ask questions. So why is it happening?
Yeah, so that's called analysis. The second step of every observation tends toward or leads towards the concept called analysis. So we as an individual, we do contemplation, we think about it, we analyze, we ask question to ourselves, we ask question to others also, we ask question to someone who knows something more than you. And then you go into the history that what everyone else has done in that segment of science. So you read research paper, you read the journals, and so you read books. Because someone has written the books, because someone has experienced before you, someone has observed before you. And by reading it, to try to understand what he was able to analyze or observe and what extra you can contribute. That is the scientific progress. Okay, so you go back to history, you see what they have done, and then based on your new observation, you try to add some new analysis. And observation and analysis leads to the third step, discovery. Then you end up discovering something. Okay, and once you discover something in your life, you want to prove it. So what do you do next? What is the next step after discovery? Verification. So you take your analysis into the process of verification, which is a very rigorous process. Now comes the real rigorous process. Here comes the mathematics. Because once you start the verification, you perform something called experiment to prove to the world that whatever I observe, the experiment is supporting my observation. So you undergo something called experimentation. And then, to put into simple terms, you create something called equation, a mathematical model. So what do you mean by equation? What is equation basically? A mathematical model. So what is model? It is a very smart, you can say, hunch or guess that things must be following this particular pattern. So model is something like a pattern. But what is interesting about model is it's purely mathematical, and therefore it can be easily manipulated. You can manipulate it, and then you can convert it into equation and you can solve it to get your desired answer. These are the process to become a scientist, from learning science to becoming a scientist. These are certain steps, and everyone has followed in their life cycle. Everyone means everyone, from Newton to Einstein to present scientists. Now, why these are important? When we are learning for, let's say, engineering, let's say IIT, JEE, mains, advanced, or whatever, we are on the path of becoming scientists because you're trying to understand science. So at your scale also, you're a scientist. Don't think that you need to have a designation of scientist to become scientists. No, you all are scientists in the very first stage. Where you are? Somewhere here. Of course, there are multiple stages that you need to go through to establish yourself. And then, of course, you need some degrees to be able to contribute to the scientific world. But this kind of mindset always helps in even learning any subject, not about physics or chemistry or maths or history. If you have this approach towards learning itself, I'm just saying learning, don't think about physics, chemistry, math as a subject. Just take these as some sort of domain of science. And they have some sort of requirement. Some requirements are common and some are different. Let's say it is generally said in class, in high school, generally, we have a perception that maths requires just solving problems. Chemistry requires mugging up the equation, formula, or you can say theory. But that is not entirely true, and that is also not entirely wrong also. There is some element which is correct, there are some elements which are wrong. With time, we have to modify our entire learning process. The very first few months preparing for competition like JEE, what it requires is the change of mindset. We have to get rid of the older methods and why it is so important. Try to understand this. Let's talk about things you have studied in class 10. So pertaining to physics, you studied certain chapters like optics, current, electricity, you studied radioactivity, you said, some machines maybe. What else? You can add anything if you want.
Sir, heat
So
and
calorimetry.
Yeah, so let's say heat and thermodynamics. Very good. So and many more. Let's call ETC, etc. You studied so many things. If I ask you how many pages you wrote as a notes, can you tell me how many pages you wrote? 200
many.
pages?
Yes, sir.
200 is sufficient, right? So I can take some rough estimate. Okay, you wrote 200 pages. The entire 10th preparation you did for 1 year, roughly. Correct? In 1 year, you wrote how many pages? 200. So you had your mindset that you see, because I know your generation is very much good with having very strong memory. You can retain a lot of information easily. And therefore, sometimes what happens, we get carried away with this idea of learning that I can remember things, but that is only possible if the content is less. What happens if the content just zooms to 2000 pages? Is it possible to revise also before examination? No. Is it possible to mug up these many pages? No. So is it possible to learn or prepare for JEE with the mindset of class 10? So some change is required, and that is obvious. Do we realize this? We need to change something. Let's say I am a teacher. What do you think? I mug up things. So when we as a teacher are teaching the entire subject, writing more than that number of pages, solving every year roughly 5,000, 6,000 numericals, do we really mug up? Or is it possible humanly to mug up? The answer is no. So there must be some method that we learned as a student itself. We all struggled. Like, let me tell you very frankly, a teacher is not smart, and at least not smarter than students. You guys are much more smarter than the present and the old times teachers, much more smart in many ways. So how we are able to retain so many information without much effort? Of course, you can claim that say you are practicing it because you're teaching every day, so you remember every day. That's true. It certainly helps to teach because we are teaching on a day-to-day basis. It helps us in retaining everything. But still, there must be some natural way to retain such a wide variety of information in a span of 2 years. Because when you're going to write the examination, you have to remember physics, chemistry, maths, all three. Now, I don't know if chemistry, if I add chemistry, the content will zoom up. Chemistry is going to be having three parts: physical chemistry, organic chemistry, inorganic chemistry as a separate entity. I am sure that it is humanly impossible to mug up all these three. Even 50% is impossible. So why I'm trying to say this? Am I scaring you? No, don't get scared. That's not the purpose. The purpose is I'm trying to shift your mindset. The class 10th methodology will not work, that you have to agree with me. That will not work for sure. And once you agree, I can give you the right idea how we are able to remember it. Okay. So what exactly teachers does to make this possible? All this hard work actually happened during our student time on. When I was like you, I did something. Of course, I did something more than regular preparation. So what we did? So I came across an idea called DDA. Now, what is this DDA? One by one, we'll try to understand the motivation behind DDA. It's a methodology. It is highly scientific, and it will help you retaining entire encyclopedia. It's a technique. So how we are able to retain so many things? The first D refers to called definitions. So how many times we try to mug up the definition for the school examination? Many times. You must have gone through this. Okay, let's mug up the definition because it is asked in the examination. Okay, we are not going to mug up. We are going to understand the definition. So the question is, what is definition exactly? What is definition? So we say it's a human construct. What is human construct? It is something that we devise for ourselves. It is like an encoded message. What is this? Encoded message. The entire content we try to put into some simple words. As a student, what is our job? To decode it. What we do? Mug up. See, there is a difference. What we were supposed to do? We were supposed to understand the message hidden in the definition. Anyone remembers the Newton's third law? Because that is the universal law everyone knows. For every action, I
Have
hope you
equal
can.
and opposite reaction.
Yeah, it's so easy to say. Have you ever decoded it in your life? Possibly, we all just go through this definition. Yeah, Shreya wants to say something. You can tell.
Yes, sir. I
Yeah, tell. You can tell in Hindi also. That's not an issue. Tell
sir
me in the
actually
way. Huh.
सर जब हम किसी को या फिर
हाँ.
स्लैप करते हैं तो
हम्म.
उतना जब स्लैप करने पे जो उसके गाल पे हीट जनरेट होता है या फिर वो उल्टा हीट मेरे हम लोग के हाथ पे भी ना इफेक्ट करता है, तो जितना उसको इफेक्ट करता है उतना हमारे हैंड पे भी इफेक्ट होता है.
हम्म.
That's why in Newton's third law, every action have an equal and opposite reaction.
But Newton never talked about the heat or energy. Newton only talked about the force. Okay, so we'll come to the
Yes,
force
sir.
part. It's a huge concept. Definitions are some sort of everything. Let me tell you the Newton's third law once again. According to this law, for every action means some sort of force. For every action, there is equal in magnitude and opposite in direction, reaction, and the action and reaction acts on two separate bodies, two individual bodies, not on the same body. Now, it is easier said than actually used in the solving numerical. Every definition that we have studied from Newton's law to other chapters, if you read carefully and slowly, in fact, we need to read slow enough to realize that what exactly they are trying to deliver or convey the message. Once the message is understood, the topic is almost understood. So definitions are the first part. And as we go through the course, we'll see how it is so powerful and why we must understand definition. We should never, ever mug up the definition. And you will realize something very interesting. With time, the definitions will become part of your memory without any effort. Without any effort. It will be natural for you to remember it. It's very natural. We will come to that. The second D. The second D is essentially something called derivation. So you all must have gone through this process of deriving formulas in class 9th and 10th, even before also. Like you must have derived the formula V equals to U plus AT using the UV diagram, right? You plotted the velocity time graph and you found the area under the graph equal to the area under the graph is a displacement, and then you said it's a UT plus half AT square. Very famous relation. We all have gone through this and we all have, lived that derivation. Derivation is the essential way to arrive at the formula, which in turn prevents the effort to remember the formula. Someone knowing the derivation can derive it. Now, as a beginner, when we all start preparing for competition, the most important step is do not remember any formula. Rather, use definition, and using the definition, try to derive it. Derive it means make a mathematical model. Every formula is a mathematical model. So when you say V equals to U plus AT, it is a mathematical model. And there is a very interesting, story you can understand. Let's say you are a big company and you are into developing infrastructure. You make airports, okay, where the flight will land and take off. You are trying to design runway, okay. Now, the flight will land only when the runway is prepared, or can we land the runway, then we'll make the flight? Like, we'll make the runway, then we'll let it land, right? Or will we land the flight and then we'll make the runway? The opposite not possible, right? So how, as an engineer or civil engineer, you can say, I'm supposed to create the length of runway which is sufficient to let the plane land. How it is possible? So you know the formula, like v is square equals to u square plus 2as. You know the plane speed, u. You know you have to stop, so you know v. And you know the engine can generate what amount of acceleration, or you can say retardation. Knowing all these things, you create the model called v square equals to u square plus 2s. This is the model. And using this model, you substitute the value to predict the length of runway, isn't it? Because you know the plane must stop. V is 0. You know that the plane is coming at the speed called u. You know that the engine's design can create retardation of this value. Because you know all these things in advance, you use the mathematical model called the predictive model, which can help you in predicting something in advance without actually happening. So I do not need a plane. I need not to first land the plane and then see how far the plane stops. Then we'll design the runway. No, this is not possible. You design it first. So how these things are possible? Using simple mathematical model, which you study as kinematics. So in high school, you say this as kinematics. But what I say, as an engineer, what I will say it's a predictive model, which helps us in predicting the simplest behavior without actually doing it mechanically. No live demo is required. A simple mathematical formula will give you the answer. And let's say the runway turns out to be 2 kilometers long. That's good enough. I will make 2.5 for the safer side. Okay. So now I will design the runway of 2.5 kilometers long, and my job is done. If I came across the runway, which is very small, let's say I have to design the airport on somewhere in the Himalayan region. I do not have the luxury of large fields. I have a very small strip, and somehow I have to land the plane. What I will do? I will create a smaller plane with the same engine, which can stop it easily. So having the predictive model, it helps us in actually converting into real life application. It seems very simple. It seems like a formula for many. But the way we should look at it is called predictive definitions or predictive model or simply mathematical model. So what you say as equation is actually called model. And it was designed by many scientists. So we have something called atomic model. It's a predictive imagination. If atom is like this, if electron is moving around the nucleus in a circular path, if it will follow the law of attraction given by the Coulomb's law, which is again a mathematical model, the formula K Q2 by R square, then the electron will have this velocity. How it is possible to understand all this? You create a mathematical model. The models are only meant for our own imagination. And we use the model to do the other discovery, to predict the other behavior without actually happening. So when you use v equals to u plus at, after time t, you know what will be the velocity. Although the time has not elapsed, but you know that if you drop a ball, if it will free fall, then after time t, the velocity of the ball will be gt. Let's say you know this. Neither you have taken any ball, nor you have dropped anything. Still you know that if you let the ball to free fall for 10 seconds, it will acquire a velocity of 100 meters per second, assuming there is no air resistance for sure. If air resistance will come, things will change. But all these are part of mathematical model. As a beginner, when we prepare for competition like JEE, what you study is called the ideal model. So every formula that we study are very much ideal, or you can say highly simplified. But that is how we begin the learning process. And when we grow up, we go for the advanced study, we try to make it realistic. And to make a model realistic, you add certain constraint. Let's say a ball which is freely falling has to face the air resistance. Now that's a realistic because air resistance is real. And this will help you in designing the idea of skydiving, okay, or propelling some helicopter, or to start your own company called the parachute travel. You want to send someone for the simple luxury travel of parachute, or maybe you want to start your company called the gliders paradise. You want to start with flying gliders or simply flying the small aircraft. Now whoever is doing all these things, they are very much you know having good idea about the models and the behavior of the models in the real life. Now once you know the basic that you study in class 11th and 12th, you can go to the advanced level, and then you can keep on adding the complexity, and then you will have the complex mechanism to deal with. So we have the computers to deal with, we have simulations or simulators basically, and that is how we create a real world application. But it all starts from where? A simple laws of motion. From where it starts? Simple kinematical equation. So isn't it interesting to study all these simple things? Looking at the future, they are going to be quite powerful. These simple ideas will lead towards the most complex real life application. And that is why you are going to learn these simple things. Of course, what I will do is during this course, you will come across all the practical application of every small thing that you study. I will tell you with chapter by chapter, topic by topic, that where possibly we can use it in our real life and what you want to become and how it can help you in becoming or achieving whatever you want to achieve. So after derivation, it's a pure mathematical effort. So we learn how to derive a formula. Comes the A part. What is A part? The A refers to application. So you take some problem, you read books, a numerical book will be there, a sheet is given by your coaching institutes. I will also give you sheets. And then you go and read the question. And after reading the question, you try to fit the right mathematical model which can solve that question. Of course, you have to do manipulation, something called mathematical manipulation. So even if you go here, the observation, there are two things here. So you can say in fact analysis will have two things. One is called qualitative, and other is called quantitative. So qualitative is like quality, just property, good, bad, nice, useful, not useful. So when we talk about quality only, let's say you ask what is the color of the sky. So you say blue. That's it. That's called qualitative. And if you ask that what is the height of the stratosphere, the height of the stratosphere, what we talk about? Some measurement, some value. It's called quantitative. Every analysis in science will have two parameters. One is called qualitative, just want to know the idea, and second is called quantitative. And the quantitative part needs derivation. And we need to learn and understand both the qualitative part and quantitative part. Okay. So after this introduction, we should move towards something that we deal with day in, day out. And what we call this is physical quantity. What is physical quantity?
So something that we can measure.
Yeah, exactly. So you go to malls, so you have the various clothing showroom, you have food joints, you have the amusement park, and you have so many things. So the entire mall is like a world, and the world with definite entities. You have food courts, you have clothing stores, you have sports gear store, you have multiple gaming store, entertainment stores, something else, fashion stores, jewelry stores. That creates a world of mall. It's like a world in itself. We live in a physical world, and whatever we are surrounded with, anything which you can either see or you can feel directly, indirectly, tangibly, intangibly, everything around us, whatever we can understand, analyze, observe, is called physical quantity. So our world is physical world, and everything in this world is physical quantity. Let's say, what is not a physical quantity? If I ask, I can say your emotion. I cannot quantify your emotion, can I? No. I cannot quantify love. I cannot quantify humanity. These are not mathematically measurable quantities. These are just qualitative ideas. Okay. So when I say the physical world or the physical quantity, then it must be having some way to measure it. If I cannot measure it, I cannot call it a physical quantity. Okay. So the world in which we live, we can say anything in this universe which can be seen, observed, felt directly or indirectly, tangibly or intangibly, are called physical quantities. That's simple definition. So anything in this universe which can be seen, observed, felt directly or indirectly, tangibly or intangibly are called physical quantities. So you say temperature, pressure, volume, mass, length, time, heat, energy, work, power, current, charge, magnetic field, electric field, whatever, everything you can say, all are physical quantities. Simple. Now the question is how we distinguish among themselves. Like, do we have some category? Let's say if we are human beings, okay, and we have some, let's say, gender. So we can classify human beings based on gender. We can classify human beings based on the job role. You may be a student, someone is working professional, someone is actor, dancer, joker, whatever. So there's a way to make a classification. Now there is a word classification. Why classification is required? Why we need to divide things into or classify things into buckets? Like we say, uh, gender-wise classification, male, female, and neutral. Okay. So why these classifications are required? In science or in history or everywhere, you must have come across classification. Let's say when you study history, you say ancient history, medieval history, modern history. You classify things, and there is a habit, like we human always classify things. What is the purpose? Why the classification is required?
To remember is things easily.
Very good. The right idea is so that we can actually decode the meaning and we put into one bucket so that we can understand easily and explain to the world easily. Distinction is actually important, because unless you do not classify, things will become messy. All things studying together, we cannot go deeper, because as you go deeper, we need to do the more and more classification. So right now you're learning physics, correct? But later on we'll study, you know what? Electrodynamics, mechanics, and modern physics as separate entity. And then you go to the modern physics, later on you will study relativity, quantum separately. Then you will go further and you will further classify quantum electrodynamics, quantum chromodynamics. So as the subject content becomes more and more, we classify to make it easy to comprehend. So classification is the essential way to distinguish based on some property. Now classification is not done randomly. I just don't choose choose a random person called you are a female and you are a male. I will not call a Virat Kohli that you are a female. Just because I'm doing the random classification. Of course, classification will be based on some properties, some characteristics. So similarly, the entire physical world is now classified. And as per the JEE level, the classification is simple. So we have put the entire world into just 3 buckets. Just 3 buckets. We don't have the 4th bucket. Entire world, entire physical world is put into just 3 buckets. The first bucket, we call it literal. Not heard before, I know. It's called literals, or should be literal. The second bucket is called scalars. And the third bucket is called, you must have guessed, vectors. So we have literals, scalars, vectors. These buckets we have to study in detail. The vector will be the biggest topic of physics. You will learn a lot about physics through vectors. So we'll talk about literals first. What are literals? I will tell you how to express them. Based on the way we express, we have classified. So what I will write here is any physical, I can just write PQ. You can understand PQ means physical quantities in short. So any physical quantity which can be expressed only with the help of numbers are called literals. Now tell me something, in class 10th you might have come across something having meaning, but we simply express with numbers. Some example. Hope it will let you realize. Refractive index. You must have come across water is having 4/3, glass 1.5. Are these numbers comes with some unit or simply number? These are simply numbers, right? Is still having some meaning, isn't it? Are these numbers just random numbers or they have some meaning? They have some meaning. What is the meaning? Refractive index is speed of light in vacuum upon speed of light in a medium. The ratio is called refractive index. So basically it's a ratio. So literals are mostly ratios. So refractive index is the ratio of two types of velocity. Velocity of light in vacuum upon in a medium, some medium. And that's why it is always more than one, because the light moves fastest in vacuum. In any medium, it moves slowly. And so if you divide a big number with a small number, the number will give you a number more than one. And so you have 4 by 3, 1.5, like 3 by 2, 9 by 8, and so on. It could be any number also. Similarly, can you give me some other example from class 10? From chapter of optics, you can think about optics. We have one thing, something ratio. Think about some ratio. Very famous ratio is there. I have given the hint also. Optics, come on. Magnification. Have you heard this name? Magnification.
Yes, sir. Ma'am.
What is magnification? Magnification is the ratio of size of image upon size of object, isn't it? I hope that this is something known to you if you have studied optics, ray optics, or you can say geometrical optics. You might have come across this terminology. Okay. Something else you can think about? So we have something like a relative density. Or to be precise, it's called specific gravity. Have you heard this name? Specific gravity? Anybody? In the fluid chapter in class 9th, because the fluid is taught in 9th class, not in 10th. Generally, maybe in some boards it may be vice versa, but mostly in class 9. What is specific gravity? Density of object upon density of water at 4 degrees Celsius. You might have heard about the anomalous expansion of water. Water behaves in a very anomalous fashion. It means if you raise the temperature of water from 0 to 4 degrees Celsius, its density actually increases. At 4, the water density is found to be maximum. Don't worry if you don't know this fact. These are something which you will learn in chemistry also, okay, in physics also. So density of water is maximum at 4 degrees Celsius. Maximum at 4 degrees Celsius, which is you call 1 gram per cc. Cc means cubic centimeter, which is also called milliliter. 1 gram per milliliter. Both are same thing. So 1 cc is called 1 ml, okay, milliliter. So refractive index, magnification, relative density. Can you tell me something more if you have some memory from class 9th or 10th? Anything. I'll keep on adding here. Literals, example, continue. So something I will tell you which you have not heard about, okay, which you will hear later in the future of this course. So we have something called strain. So there is a symbol in set theory. You know the symbol? Belongs to symbol?
Yes, sir.
Yeah, this symbol is actually called epsilon. It's a Greek alphabet. it's called epsilon, and therefore the strain is a ratio of changing size of object upon original size. Let's say you take a rubber band, you stretch it, length will change, correct? So the change in length upon the original length, the ratio is called strain. You might have used the word nerve strain. So when you take a high rice pillow, in the morning you get a neck, strain in the neck. We call nerve strain. The strain means the deformation in something. Okay. So this ratio we call strain, which is also literal, and it is having some physical meaning that we use in a chapter of properties of matter. That will be the last topic of your class 11th course. We have something more which will be totally out of blue. I mean, of course, I'm just mentioning so that when you come back to revise after 1 year, maybe, then this will be helpful to you. But don't worry if you do not get it totally. That's totally okay. So we have something like a Poisson ratio. Don't worry about it. Just let me write down. I'm just trying to finish it. So there we have something called Poisson ratio, which is defined as the strain, the transverse strain upon longitudinal strain. That's something, don't worry. It's something which you should not be bothered about. Okay. And what exactly it is, if you want to understand, when you stretch an object, as a result of stretch, the length will increase. Correct? But at the same time, something will decrease. What will decrease?
The width.
Yeah, correct. So length will grow, the radius will shrink or will become less. So the change of length, this is called longitudinal. What we call? And this contraction is called transverse. Just for your idea. Don't worry if you don't get it. That's totally okay. Okay. Some more example from the anyone from the ICC board?
Yes, sir.
So
Yes,
you
sir.
might have heard about something called mechanical advantage.
Yes, sir.
In the first order machine, the pulley and the chain system. So what is mechanical advantage? It's called load upon effort. And again, it's totally okay if you don't get it. That's totally okay. So if you try to pull something, so if we have a pulley, this side we have some load, and you're trying to pull. Now, if we have single pulley, the load, which is nothing but the gravitational pull, and the effort, which you are applying the force, both will be equal. But if you create a multiple pulley system, the load will be mg and the effort will reduce because now we have two ropes to pull it upwards. We have two ropes, so our effort will double here. And if you keep on increasing the number of pulley, you can reduce the effort to pull the same load. So this is called effort. So the whole purpose of creating the chain pulley system is to pull the load with least effort, right? So we create a series of chain and pulleys, and our effort will divide. So you can pull 10 times heavier object than you with a very little force if you can do the mechanically this arrangement. If you make the chain pulley system, and the more number of pulley if you bring into picture, it will be easier for you to pull the object. So those things are there called mechanical advantage, and we study these as machines, but in the Newton's laws of motion chapter, we'll study as the laws of motion concept. So we'll study, of course, about all this in a chapter after vector. Now, we also have something called velocity ratio. In the same thing, in the theory of machines, you might have come across, but if again, if you don't have, I mean, know about these things, if you have not heard, it's totally okay. I mean, no need to worry about all this. So in JEE, we do not need all these ideas. I mean, we can derive it from very basic. It's pretty easy. So these are some of the examples. Let's go back to the classification of the physical world. So these are the physical quantities which you can express with the help of just numbers. What you need, a pure number, which may be fraction also. That's totally okay. Fraction is okay. So literals are also called physical quantities. Okay, literals are also called physical quantities, and these physical quantities can be expressed only with the help of numbers. We do not need anything. So now comes the next category. So I'll put it on a separate page. Let me pack it. So the next is called scalars. What are scalars? If I ask you, what's your height? Can you express in number? No. If I ask you, what's your height? Can you say that my height is 5 feet 2 inches? If I remove the feet and inches, does it make any sense? If I ask you, what's your mass? If you say 40 or 50 or 60 without the number kg, does it make any sense? So what you can realize that numbers are not sufficient. We need unit of measurement. So numbers plus some unit of measurement. When a number comes along with a unit of measurement, then we call this combination, you know what we call? Anybody who knows?
Magnitude.
Exactly. The combination is called magnitude. So this together we call magnitude. That is why I never used the word magnitude before. I never said the refractive index is having magnitude 1.5. I never said, it's just number. So number coming with the unit of measurement we call magnitude, and that is the characteristic of scalar. To express any scalar, what we need is just two things. You give me a number and the proper unit I can express. And we are trying to understand the classification in terms of the way we express, not the exact things. Like, it's a very complex topic. We'll discuss one by one. So what we can say, scalars. I'm not saying who are scalars. I'm saying if you are a scalar, then you need two things in order to be expressed: numbers and a proper unit of measurement. Simple. So what are scalars? Physical quantities which can be expressed only with the help of numbers with proper unit of measurement. Okay, can we say that the scalars don't have direction?
Yes, sir.
Yes, sir.
Yeah. So we all have studied that scalars don't have direction, right? But in physics, in JEE preparation, you will come across even scalars can have direction. Oh my God. It's the biggest change, the breakthrough. Scalars can have direction.
Sir, so are those exceptions, sir?
Basically, such scalars are actually called tensors in the advanced physics, but at JE level, we simply call, or you can say we simply put into the bucket of scalars. So there are quantities like pressure, stress, and even current density. Not current, moment of inertia. So these are, of course, you have not heard about all these things, but there are a category of physical quantity which are actually called by the name tensors, but they are put into the bucket of scalars because in JEE syllabus we cannot introduce tensors. Okay, that's the problem. Understood?
Sir,
So
but if these quantities have direction in them, why are they not put into the
that's
vector bucket?
correct. That's a good question. So let's say, okay, anyway, I have to explain this. This question is something which needs a better explanation. But let me tell you something interesting. Let's say let's say you all are preparing for some competition, okay, or maybe just science. You're preparing for science, you love science, you're preparing for it. Imagine every person preparing for competition, will all are going to qualify? No, only few will qualify, but all are preparing, right? So to qualify, you need to write some sort of examination, isn't it? To qualify, you need to write some sort of examination called qualifying examination, named JEE mains and then JEE advanced. Once you pass those examinations, what you become? IITN or NITN, something like that. Okay. And once you pass through the 4-year course, you become an engineer by degree. All right. So basically, in physics, vectors are like some sort of qualification. Like you have engineers, doctors, vectors. Yeah, in that way. Exactly in that way. Engineers, doctors, lawyers, vectors. So to become vector, direction is not required. Of course, you need to prepare. You should have the magnitude and direction. But having magnitude and direction will not qualify you as a vector, because vector is a qualification. So to become vector, you need to have magnitude, direction, and something more which you have not come across in class 10 or 9.
So vector law of addition.
Yeah, exactly. So the vector law of addition is the qualifying examination. If you pass it, you will be designated as vectors, like lawyers. You pass the MBBS to become doctor, and you pass the NIT or IT become, or any college, you become engineer. So having direction, so pressure is something having direction actually, but it fails to qualify the vector law of addition. So it was put into the category of scalars. Of course, it's called tensors also. Moment of inertia having the same problem. It is having some sense. It is like a tensor, and not moment of inertia. You can say stress. Stress is having the directional property, but it never follows the vector law of addition. The problem with the quantities, they fail the law actually. and that is why they are put into the bucket of scalars. We'll talk about in detail in a chapter of vector itself. We are coming very close to that topic. Maybe in 1 or 2 class, you will be exploring much more than what you are expecting here. So scalars are those physical quantity which can be expressed with the help of numbers and proper unit of measurement, together called magnitude. Okay. So the number and the unit of measurement, when you talk about it together, we call it magnitude. And the examples are, I'll give some different examples, the examples which you are not very much regular with. Pressure having direction. Okay. Same is with the stress. And the very famous time. Okay. So time, time is also having direction. Time always flows from the past to present to future. There is a sense of direction, right? Not a physical direction, not a direction in space. It's like emotion, past to present to future. This is called, in advanced physics, we call it a temporal sense of direction. But that's totally okay. I mean, this is not required. And anything with the temporal sense of direction is not called vectors. I mean, of course, you have a sense of direction, but this is not a physical or spatial direction. We need direction in space, not in time. Okay? In the Einstein world, these are vectors. Yeah, you heard it right. In the Einstein world, in the relativity, these are vectors. These are treated as vectors. We have something called 4 vectors. It's an advanced theory. And time is treated as actually vectors. Yeah. But of course, not at the JE level. So need not to worry about all these things. There are many things which will disrupt your ideas, your establishment of thought process. It will disrupt. Not get confused with all these things. These are just to distract everyone. So leave it. JE will only focus on JE domain. I'll give you extra knowledge, but not for confusing you, just to understand, okay, things are quite different going into future. So pressure, stress, time are scalar quantities, and one more quantity which is very special is called angles. Yeah, theta. Like you measure angle, yeah. These are scalars. Okay. So we call finite angles. These are like a non-typical example. Let's talk about the typical example. Mass, volume, density, temperature, distance. Tell me something more.
Speed.
Yeah. So yeah, you can say speed. Then
Acceleration.
Work and energy.
yeah,
Acceleration vector.
no, acceleration the vector. Work, energy, or any form of energy. And anything which we define with the help of these things are going to become scalars one. Okay. So we have something called intensity, power, and you can say etc, because there are many, of course. So these things are scalars. Okay. The unique one I have mentioned in the top, because that we'll discuss a bit in detail, like why they are not vectors, although they have the sense of direction, but they are not. And yeah, one more thing I just forgot: electric current. So current moving in the wire having direction, isn't it? If the wire is from north to west, north to south, let's say, The current has to flow north to south. No option. So you can see that these are quantities which can have direction. But are they vectors? Is current a vector quantity? The answer is no. Why? Because a current of 2 ampere coming from left and 2 from right will become 4 actually, coming this way. But in vector, 2 from right, 2 from left will become 0. So in vector, if you have equal and opposite, they cancel. Current will never cancel, they will add up. So definitely, having direction is not the issue. The issue is, do you follow the laws of vector addition? If the answer is yes, you follow it. Welcome to the world of vectors. Else, be there wherever you are. Okay, that's a whole idea. Then how to express vectors? I'm not saying who are vectors. I'm saying if you are vector, then what I need? So I need 3 things. So to express vector, you need 3 things. What are the 3 things? You need number, unit of measurement,
And direction.
and direction. So let's say if I tell you that the distance of your school from your house is 5 kilometers, is it sufficient information to reach the school? You need to mention in which direction I need to move. And that's logical. I mean, of course, I mean, just knowing the number and the measurement also is not sufficient to express it. So to express the location of your school with respect to your home demands or requires a vector quantity. We call it later on we will call position vector. So it will come across this chapter of vector. So let's talk about some examples. The unique one, unique vectors. So these are some very unique name. Elementary angles. I mean, what are elementary angles? Don't worry again. We'll study at the end of the chapter of vectors. Elementary angles, which we represent d theta. D is something like the small, you know. Let's say, what is d theta? Let me tell you something interesting. Which number comes after 0?
1.
So half comes after 1. Oh. Can we say the number after 0?
No, sir. Infinite.
We cannot say it, but there is a number after 0, isn't it? Can we say it?
Yes.
You can say it. So which number is after 0? Tell me.
No, sir. As in, you cannot express it.
Exactly. But there is a number after 0 which we cannot express it. It is exactly like a God. You know it. It's there. You can't touch it. You can't bring it into existence. There comes the idea of elementary. Newton was very much worried about such situation. He said that what number comes after a given number? And if it comes, how to express it? So he said that a number, let's say theta, is a number, some symbol. The next number will be theta plus d theta. This is the number next to 0. If this is 0, this is number next to 0. If this is theta, this is the number. This is the number next to theta. Theta, and what is this? Number next to theta. And then he devised something called d theta. What is d? The smallest possible imaginary idea. D means smallest. How it came actually into picture? You might have heard about the delta, the big delta symbol. And when you say delta something, let's say delta x, which means x2 minus x1. You said delta y, y2 minus y1. You said delta u, u2 minus u1. Delta means what? A big change. So from delta, we came across something called a symbol like this. This is called the small delta, and we call it del. So delta is a big change. Then we have a del. You can think del as a small or not small, very small change. Very small change. Big change. And then comes the D, the smallest possible change. Like it's just emotion, you cannot express it. It is same as the number next to 0, which I cannot express it, but I have to express it. So I say that this is the elementary change. And whatever you write after this symbol is the number in which the change is demanded. So when I say dx, so it means elementary change in x. If I say dy, elementary change in y, which means the next number to the y. So if I say d theta, the number next to theta, like the angle is theta, let's say 30 degree, and the d theta is the 30 degree plus the next number, which is impossible to define. So how we express it? By the symbol d. So d theta, dx, dy. Understood? What is a d? So can we actually understand this number? The answer is no, but we can just have the emotion for it. The number next to any number, we add this particular way. So the theta is some hypothetical value. The very next value we call theta plus d theta, because d theta is the next smallest possible elementary change. Okay. And what I'm saying that elementary angles are vectors. What I said here, finite angles are scalars. Big angles are scalars. What I'm saying here, elementary angles are vectors. Now you may ask why, sir? I will explain in the chapter of vector. It requires great deal of explanation. It comes under the topic of vector addition. So when I will be teaching you vector addition, I will be teaching you the definition of d theta, why it is vector. And as I said, to become vector, you need to follow vector law of addition. And fortunately, small angles follows it, big angles do not follow it. How it is following or not following, we'll explain in the chapter of vector. Don't worry about it. Some unique examples. Area. Yes, you heard it right. In physics, area is a vector. In physics, and of course, we have some interpretation. So area is a vector quantity. What about the volume? It's a scalar. You can see area is a vector, but volume is a scalar. Why it is so? Again, this is the last topic of vector cross product. So when I will be teaching you cross product, I will explain you why area is a vector. As of now, just hold your breath. Some more unique example about vectors, area, elementary angles, and anything else which I'm missing. Something very unique which you will study at the end of this entire course. Pointing vector. It's a flow of energy. So although we call energy as scalar, but the flow of energy becomes vector. Interesting enough. These are very unique definitions, which is not generally heard or written directly. You will come across only if you have studied vast amount of literature in physics. Area is very common in physics. You have to use it very, very often. The entire class 12th chapter called electrostatics will deal with area vector aggressively. So don't worry. I mean, of course, you have one more year to get mature enough to learn that concept. So be relaxed. Okay. Then let's talk about the regular stuff. The regular stuff. So tell me some other example of regular vectors.
Velocity, acceleration.
Yeah. So we have displacement.
Moment.
The momentum, of course. Displacement. Just velocity, of course. Acceleration, of course. Force. Oh, momentum, I missed. Impulse. Torque. Angular momentum. Angular impulse. I mean, so many.
So weight.
Yeah, of course. Angular impulse. Weight, of course, because that's a force. We can say electric field, magnetic field, gravitational field. All are vectors. I mean, I can put ETC. I mean, there is no end to it. So all are vectors. So far, what we have seen is simply how to express the buckets. Like our world is now classified into 3 buckets. And the buckets will have some sort of physical quantities that we need to deal with. And essentially, these buckets are 3 as of now. Of course, there is something called tensors, which is not part of the JEE syllabus. Those scalars which we demonstrate as scalars with directions are basically tensors. Okay, so we'll come to that. These are tensors. Anything which are in the bucket of scalar and having some directional property, you can directly call as tensors. Okay. So now comes the actual definition. Now we'll start the chapter of vectors. Oh. So now we'll define what are vectors, who are vectors. Rather, I would say who are vectors, like who are doctors, engineers, how they become vectors, what make them vectors. Just magnitude and direction? No, that is not sufficient. So what we define? So those physical quantities having specified, okay, having magnitude. Now magnitude means number and unit of measurement together. Okay, so 2 things coming together we call magnitude, comma. Now comes the word specified direction. which means direction must be unique. The problem with the pressure is at one point, pressure can have all possible directions, right, left, up, down, everything. The problem with the pressure is it is not specified also. Okay, so when you enter the liquid, you might have studied that as you go down, the liquid pressure will increase by the formula rho g h, something like that. The density, gravitational acceleration, the depth from the surface. And at a depth inside the liquid, the pressure will have direction, but not unique. Direction depends on the body, what is present there. So we'll talk about this in a while. And that is the problem, that pressure never become vector. So those physical quantities having magnitude, a specified direction, and which follows the rules of vector addition strictly are called vectors. Okay. So now we will discuss in one by one. So let's begin with some simple example to set the intuition right. We have, let's say, two blocks or just one block, and I am applying a force of 10 Newton from this side, and I am applying a force of 10 Newton from this side. Both are 10 and 10. So what is the net force acting on the block?
0.
Okay, but how 10 and 10 become 0? So definitely or certainly you're seeing something else. Okay, if I have a bucket, if I pour 5 liters from this side and 5 liters from this side, how much water will I have?
10 liters.
Definitely 10 liters. But here 10 plus 10 becomes 0, and here 5 plus 5 is 10. So is this normal mathematics? Oh my God, you have
Both are in the opposite direction.
Yeah. So okay, when you say 10 plus 10 0, what comes to your brain? Like, I mean, how your brain says this 0? I want to understand. What exactly happened in your brain that you said 0?
Sir, because opposite direction, so it cancels.
No. This was not in your brain. I will tell you what was in your brain. You saw that the block will not move. You realize actually. This is like something implicit. Your brain understood this will not move. Come on. No matter what, it will not move. And you said, see, the absence of movement in your brain let you say this answer actually. You have no idea about physics. You're doing the intuition. And what is your intuition? The motion. And you use your emotion to understand there is no motion, and you said 0. You never said 10 plus 10 is 0. You said 0. So one thing is clear. We never talk about number. We never add number. What you were adding here? Can you tell me? You are adding in your brain the effect of force. Your brain was able to understand the effect. Okay, let me remove it. See how it happens. Now I remove the force from one side and just apply from this side. What is the force now? In this case, what is the force acting on the block?
10 Newton.
10 Newton. That's obvious. Okay. And I'll do the third scenario. Try to understand, like, we are trying to decode the brain. The brain is actually deceiving you from the right reason. The reasoning is not strong. That's called observation. We are so far trying to use our inbuilt intuition to answer. You are answering because of your powerful intuition. not the reason. Look at this. What is the force now?
20.
20. Why 20?
Because it's in the same direction.
Yeah, because they can create similar effect. Both acting in the same direction will must or will, not will, they must create similar effect and the effect getting added. So whatever the first force is able to create, the second is also able to create the same effect, isn't it? And because we are doubling the effect, the answer we are doubling in a way. So you are saying 10%, 20. In the first case, you said 10% 0. Now you are saying 10%, 20. Imagine such mathematics if you tell your parent that I learned today that 10% is 20 also. Your parent will beat you black and blue because the entire investment to teach you basic maths is gone wrong. 10% is 0. I mean, come on. I am damn sure that we are moving towards a new world of mathematics. This is not a regular mathematics, in which sometimes 10% is 0, sometimes 10% is 20. What kind of math is that? I really hate it. So this is a branch of physics. No, this is a branch of mathematics. What we call is called vector algebra. It was a big lie that I'm going to teach you vector. No, I cannot teach you vector. I can teach you vector algebra. Vector, vector is simple definition, which is done. Whatever you're going to learn in this chapter is called vector algebra. It's a new branch of mathematics actually. So what happened in the past? They realized this kind of effect, and that's called the cause and effect way of learning. A force is a cause which creates some effect, and with your own intuition, you're just adding the effect in your brain. Somewhere the effect is getting added. Now, if I ask you like this, the fourth scenario. If I apply a force of 10 from this side and 10 from this side, don't try to answer the question. Try to understand the effect. How the first 10 will create the effect, in which direction, right? And the bottom 10 will create the effect in which direction? Up. Now tell me common sense. Are these effects equal or unequal? These effects are equal in the respective direction, isn't it? These forces are able to create similar effect, isn't it? The effect is similar, the same here, same here. So how the block will move? This way or this way? Now the block has no choice. It will try to create the net effect like this, the angle bisector, isn't it? Now you may ask, why bisector, sir? Why bisector? Because I cannot be biased. I am unbiased person. If effect are equal, then I must move in the direction which is like unbiased. And the only way you can remain unbiased is because being in the middle, equally inclined to both, isn't it? Now imagine the fifth situation. Before you learn vector, you have to learn 10 times. What do you mean by vectors? So let's say this is the force of 10 Newton, and I'm doubling the force from bottom. Let me make it 20 Newton. Don't try to solve the question. Try to understand the geometry. The effect this way, but the effect upward is going to be double. Can you see the effect? Now, how we express the double effect? You can see what I'm doing. I'm actually drawing a bigger arrow. See the smartness. To express the effect, I'm doubling the length of arrow. That is exactly we do in the vector representation. The magnitude we represent by the length. A bigger effect means bigger length. A small effect, a small length. The length is my visual method to express the magnitude of effect. So vectors are expressed with the help of arrow because of this reason, so that you can stretch it, shrink it, invert it based on the scaling. So this is called scaling in physics, in mathematics. What you are doing is you are scaling the number. So you have scaled the effect double in the upward direction, and 10 is right. This is 10. This is 20. Now you tell me, I should be more inclined towards the resultant. The net effect should be where? Middle,
Towards the north.
up or down?
Up.
Up. That's logical, no? That's quite logical. I'm not doing anything from physics point of view. What I'm trying to say that this is natural. And this natural thing was actually observed by various mathematicians. In fact, they realized that it is following some sort of Euclidean geometry. You know Euclidean geometry? The geometry in a plane. So this branch of mathematics having the influence from the Euclidean geometry, or you can say it is based on the and this length is called the resultant. What do you call? Or what is the meaning of resultant? The net effect will be in this direction. And since length is a way to express the magnitude, so if this is of length 10 value, if this is of length 20 value, what is this length? Can you tell me this length?
30.
The length is how much? You can use Pythagoras. That's the only rescue you have. All hail the Pythagoras. Without him, the entire algebra is baseless. We cannot create algebra without Pythagoras. So if this is 10, this is 20, this length will be how much? Under root of? I hope you know the Pythagoras.
500. Root 500.
Root 500. Very good. 20 square plus 10 square, root 500, which is equals to 10 root 5. The value of root 5 is 2.23 something. So 10 into 2.23 and something, which is roughly 22.3 Newton. I'm just taking the rough value. Similarly, can you tell me the net effect here will be what length? If this is 10, this is also 10. What do you expect here? The length will be how much?
Root of 200.
Root of 200. That is 10 square plus 10 square. And that's logical because this is nothing but the 10 root 2. Right? 10 root 2. Of course, we will study all this in a systematic manner, but what I'm trying to explain is we are entering in a world of a new mathematics. And you are supposed to understand the mathematics, not vectors, not physics. Physics is going to use it for its own purpose. And what is mathematics? It's a language of physics. You express your emotion in a mathematical way. Once, long time back in way back in 2007, I remember very distinctly a class 6 student asked me one question. So I was teaching him. He was from London, and he asked a very simple, nice question. 2007, yeah. He asked that why we have variables in algebra. See, this is a class 6 student question. He's asking something really nice. Try to understand. He's asking why we have variables in algebra. Try to answer. Why we have X and Y? It was a tough question for me to answer. So I gave him simple example. Imagine I said, okay, what's your age? He said something about 14 years or 13 years, something, maybe less than that, 12 years. So he said, my age is 12 years. He asked, what's my age? I said, okay, this much. Okay, okay, let me not reveal it. So it was let's say 22 years, 23 years. So I said, your age is 12, my age is, let's say for mathematical simplicity, my age is 24. Okay. So let's write into the paper. My age is 24, your age is 12. Isn't it cumbersome? So what if I say my age is X, your age is Y? So if I call my age as X, so next time I need to write my name is, your age is, this is literature. And literature is not a convenient way to write a lot of mathematical manipulation. So we design a shortcut. We call it variable. We assign it. I say, let's your age is X, let's my age is Y. Now, next time I need not to write the literature, I can write X and Y. The very next question he asked, then why we have coefficients? You can see clearly my age is twice of your age. Y equals to 2 times X. The 2 is called coefficient. So we have coefficient to create the or to write the exact relationship. In variables, the coefficients are the scaling factors. You scale the variable to make it equal to some other variable. In a way, if variables are family, their coefficients are the relation, how you're related. Okay. Similarly, in the vector, because they are not following the regular algebra, the algebra which you are aware of, where 2 plus 2 is 4 always. Here you can see that 10% becomes 0, sometimes 10% becomes 20. So definitely we need to create a new branch of mathematics. And can we convert a branch or create a branch with literature, or should we have some symbol? What do you believe? We should have some symbol, or you're okay with literature way of creating mathematics? Which is more convenient?
The symbols.
Symbols.
So if I give you some symbols, you should not be bothered, right? You should understand that, okay, this is required, come on. So if I say vector prasansa, vector siddhant, vector share, vector me, it's very bad. I can just name it A, B, C, D, and so on. So I can say S vector, P vector, SH vector. So when I say when I take some symbol and put an arrow, what I'm trying to do? I'm trying to just create a dress code. These guys are vectors. And how to distinguish from the other code? You put an arrow. Just like the lawyer will have some sort of cap, doctor will have some sort of apparel, white apparel. Engineers will have the yellow, you can cap. You create some sort of distinction. It's just like, in our day-to-day life, we create the distinction by having dress code, uniforms, and so on. Every school will have different uniform, right? Because they want to distinguish from others, isn't it? Imagine the entire India having same uniform, same dress code. Anyone can enter any school, isn't it? Difficult to manage. Okay. So the idea is, in the world of vector, the first thing we need to understand is what will be the correct representation. So the first thing first, what we call is representation of vectors. And we have two types of representation. One is called symbolic, and second is called graphic. What you just saw in the previous page was graphical. So what is the symbolic representation? You just choose any alphabet, A, B, or you can use Hindi alphabet, you can use something from Urdu, whatever language you want. Okay. I just put an arrow. An arrow does not mean right or left. Arrow means just a address code. You are belonging to a particular set of vectors. I mean, a set of physical quantities called vectors. So, sir, can we use only one alphabet? No, you can use any number of alphabets. You can say A, B, and then arrow. So, can we use only two? No, you can use any. I mean, you can use three also. So, can we use only A, B, C? No, you can use even symbols also. You can use some alpha vector, some delta, and any fancy. You can create some sort of like a rat vector, maybe a cat vector. Like it's just a name. It's just a representation. It has nothing to do with any emotion. Choose whatever you want. You can create some animation. Okay. So let's say you love football. You can say this is my vector, a football vector. That's okay. Totally okay. So vectors can be represented graphically by putting an arrow and one more thing that is again very famous, or by putting something called cap. So this is called cap, but in American authors they use hat. So British uses cap, American uses hat. There's a difference. I mean, they use different literature. So how we read this? A cap or a hat. Okay. So these are different notation. Graphically, you can choose. You can use the full name and put a vector. That's totally okay. You can just write your name. You can say Lotus vector. That's totally okay. Or you can say America vector. That's totally okay. Vector is just a, these are simply representation that you belong to a category of vectors. The arrow is not showing any direction. You're saying that you are a vector. It's a uniform dress code. That's it. Okay. Now graphically is interesting. So graphically what we do, since we know that every vector will have some magnitude and direction. So graphically, because it's graph, so graphically what we do is we draw on a paper. Normally how we draw vector? On a paper only, on your notebook, right? So on a notebook, you draw some length, some line. So what we write here is graphically vectors are represented by a line segment proportional, okay, by line segment with an arrow, where line segment represents proportional magnitude. Simple. So graphically, vectors are represented by a line segment with an arrow, where line segment represents proportional magnitude, and oh, I missed it. And arrow, its relative direction. No, we'll talk about this in detail. So graphically, vectors are represented with by a line segment with an arrow. Okay. Normally, what happens if I draw something like this? What you will call? It's called ray. Ray, you know ray. There is a beginning and there is no end. So if there is no end, it means it's not finite. It is going to infinity. So a ray represents infinite length. But a vector cannot have infinite magnitude, right? A vector will have finite magnitude, and therefore we need a finite length. That's why a line segment with an arrow which looks similar to the ray, don't get confused, both are not same. Okay. And can we represent direction on a paper? Is it possible to actually represent direction? No. So can you tell me where is north on paper? No, I can't. There is nothing like north and south on a paper. On paper, we name it, we call it. So we can call this as north, this as south, east, west, up, down. Now I could have written north like this also, but the moment I write north like this, south becomes like this, east like this, and that's why we call news. North, east, west, south. Okay. So what if I draw the north like this? Totally okay. But the moment I draw north like this, south becomes east, west. So on the right of north we have east, on the left of north we have west. So these directions are absolute or relative? What do we call it? Absolute or relative?
So relative.
Exactly. Because once you call one direction as north, other becomes accordingly. If they choose the direction as per what you choose the first one. Okay. On paper, we can only do the relative direction, not the absolute. And that is why I use the word relative. I hope this part is clear. Like what is relative here? We cannot draw absolute direction. That's simple. And the length segment, any arrow put over the length line segment will represent a vector where the length of the line is the proportional magnitude. Why proportional? So let's say I may choose, depending on the size of the paper, I can call, let's say if I call 10 Newton as equivalent of 1 centimeter, it's called scaling. So if I want to draw 10 Newton, I will draw 1 centimeter long, like this. So to draw 20 Newton, how much length we need?
2 cm.
2 centimeters. So let's say 10 Newton east, and I'm putting this as east. So can you plot on the same paper, 20 Newton north? How it will look like? Can you guess?
2 centimeters towards the north direction.
Just a moment. So the moment you call east right, north becomes upward. And therefore, because 20 north, it must be drawn like this. A arrow with double length pointing in this direction. So if I call 30 Newton south, how to represent? By a line thrice
3
of the
centimeters towards the south.
down. So do you realize that how easy or convenient it is to express vector once you decide what is first vector? And that's why I call it proportional, because if I choose 10 Newton as one, the 20 becomes double and 5 becomes half also. Okay. So the vectors are represented by a line segment with an arrow. I cannot say ray. I have to say line segment with an arrow, because a line segment is finite, a line is infinite, isn't it? Okay. So there is a very beautiful story which I faced in 2008. I was in Delhi, and it was the Krishna Janmashtami, you know, the Lord Krishna birth festival. So I went to ISKCON temple. Like if we have in Juhu, if you are from Mumbai, you know, we have in Juhu. So I went to ISKCON temple, and it was long queue. Okay. And there was a toddler, hardly 5-year-old toddler, sitting on the shoulder of his dad. The toddler asked one simple question to his dad. You know what he asked? He asked, "Dad, why this line is not ending?" Imagine what his dad to his 5-year-old toddler must be answering. What he asked? "Dad, why this line is not ending?" His father answered, "Line never ends, only line segment ends." It's a true story. I realized that his father must be a mathematician. This normal answer is not possible. I mean, this is abnormal answer. I think in our life, no one has said like this to a 5-year-old child, because he was sitting on his shoulder. So I can guess he must not be more than 5. This is a true story. I mean, this is such a powerful story that I cannot forget. And every time when I start teaching this vector chapter, I always share with every student. I have been sharing this since 2008 onwards. So line never ends, line segment ends, and vectors are line segments, not line. Okay. Vector essentially, or you can say naturally, follows the Euclidean geometry. And therefore, the triangle law is the consequence of the triangle property of geometry. So what is the triangle property? If you draw a triangle, very common thing. What is triangle? If you add any two sides lengthwise, it is going to be bigger than third. You can choose any two sides. And similarly, if you subtract any two sides, it will be less than third. That property is already inherited in the triangle law, or you can say triangle. So in this chapter, what we are going to learn that the way vector gets added together will naturally follow the triangle law. And that's why the triangle law becomes the de facto of the test. Like IIT is the examination which you crack, you become IIT. The triangle law is the test that if they pass, they become vector. If they fail, gone. They're thrown out of the world. So they live with the scalars, a very mediocre life. Of course, scalars will have their own benefit. Okay. So generally, what you like? You like vectors or scalars? Okay, you will realize that you will hate vectors in future. The scalars are the easier to go. Okay. So you will like energy more than anything else. Okay, so we'll see that. Of course, vectors are required to be focused in life, to be having direction in life, to have motivation in life. So vectors are also required, and of course, the convenient way to learn physics is scalars, the energy method. So we call it energy method to solve any question of physics. So as we progress in the course, you will see that with time, you will be able to explore more and more like depth of every single topic. So you will see why we study whatever we study, like the why will be clear. Now, what are my suggestions going forward? My suggestions are simple. Right now, of course, there is no homework because I haven't taught you anything. It will take some time before you get some homework. Once you get homework, it will be too much actually. So the first thing is every definition which I have written, then let's say I have written few definitions today, right? Just few definitions, not much. Can you remember naturally without putting effort? Some natural process you can synthesize in your brain and make it part of your brain. Can you do it? Like if I ask what is literal, so can you just tell me the answer? I'm not saying mug up, but is it going to be a part of your natural part of your memory? If you can do it, it's really good. Try to remember all definitions. Read few more times. I will be sharing this PDF with you guys on the group. Okay. And once you get the PDF, you can revise. I will be sharing the recording also. Whatever I have taught you today, it will be recorded and it is now sent to you. Your job is to save the lecture, put in a folder, and put topic wise. So you will start a folder vector. In the vector, you can put lecture 1. It's better to put the keywords so that you can search easily. So you can put lecture 1, physical quantity. That's it. Then lecture 2, triangle, or you can put some keywords so that you can search easily. So start making folders. So you will have all the repository. And again, whatever you learn today, you will not remember forever. You have to revise. Revision is required. But don't try to revise from video until it is urgent. Try to revise from the PDF, which I'm going to share. Right now, there is no derivation. It's just definition part of discussion. But once the derivation will come, again, my suggestion is do derive at least 3, 4, 5, or n number of times till you realize, till you feel about it. Until you're not feeling, keep on deriving. Okay. In the very beginning, focus more on concept, not on examination, not on marks. Number of marks will come if you're good with your theory and concept. First few chapters of physics are transforming years for you guys. You will be getting into the entire new methodology of learning. So keep patience, stick to the basic, do the required, everything will be good. Not good, the best. Okay. So with these words, I will say bye to all of you guys. We'll see you in the next lecture. The next lecture will be on Monday. Okay. So we'll keep on Monday and not Monday. I mean, I'll tell you the next date. I mean, maybe on Friday. Okay. Today is Wednesday, Thursday, yeah, Friday. So we'll keep on next Friday. So we will meet again on Friday, and then you will get few days to practice. By next lecture, you will have sufficient theory to practice sufficient problems. I will be sharing the entire sheet, PDF, and recording as well. Bye-bye and take care. See you next class.
Bye, sir. Thank you.
Thank you, sir.
Bye, sir. Thank you.
If you want to ask something, you can ask. Of course, lecture is over. Any doubt pertaining to anything, whatever we discussed today, if you have doubt, you can ask. Shreya, you want to ask something?
No, sir. No doubt.
Siddhant, you want to ask something?
No doubt, sir.
Okay, Prashant, so I'm leaving for the day. Bye, guys.